Today's lesson is about math properties. We're going to go over some properties that you probably learned in elementary school, such as the commutative property and the associative property, and you're going to learn some new properties that are going to help you make solving math problems a little bit easier for you. So let's get started. The first property we're going to go over is a property that you should be familiar with. It's called the commutative property, and what it tells you is that you can change the order of numbers when you're adding or multiplying without changing the answer to a math problem. So the property, like I just said, applies to addition and multiplication. And let's look at some examples. So here we have the first problem, 8 plus 5 and 5 plus 8. You can see the numbers just change order, but when you solve both of those, you'll find out 8 plus 5 is 13 and 5 plus 8 is 13. The second example shows one for multiplication. Again, it's kind of like a mirror image. 4 times 9 is equal to 9 times 4. If you solve either one of those, you know your times tables, right? So 4 times 9 and 9 times 4 are both 36. A little more complex example, it just adds an extra number and some parentheses. So this one shows all addition, so every sign is addition. There's an equal sign in the middle. And what you'll see is that the 12, which is not in the parentheses, just goes from the front of the problem to the back of the problem. So the order of the numbers is changing. But when we solve these, we're going to get the same answer on both sides. 6 plus 8 is 14, 6 plus 8 is 14. Using PEMDAS, that's why I did the parentheses first. And then the problem turns into a problem that looks very similar to the ones that were on the last slide. It's kind of a mirror image. 12 plus 14 is equal to 14 plus 12. Both of those addition problems have a sum of 26. So that is your answer, and that proves that the commutative property works. Multiplication problem here, same thing. Every sign is multiplication. The numbers are all the same. The only difference is that the 2 goes from in front of the parentheses to behind the parentheses. So when we solve the first step by using PEMDAS, we get 30 for our 10 times 3 on both sides. And it turns into a problem again like the very first two that I showed you, where 2 times 30 is equal to 30 times 2. Both of those math problems have a product of 60. Okay? Why doesn't it work for subtracting or dividing? Well, best way to explain that is to show you some examples. So that sign in the middle that has a slash for the equal sign, that sign means not equal to. We're going to learn about inequalities this year, and that symbol is going to be in that unit. Now here's a nice introduction to it. If we solve these problems, we're going to see that the two sides are not equal. So for the first problem, we all know that 12 divided by 2 is 6. But 2 divided by 12, if you solve that, is actually going to be 0.16, and the 6 repeats. On the other side, 14 minus 5 is 9. We all know that. If we use our integer rules from the very first unit of the year and do our keep, change for 5 minus 14, we're going to see that the difference of those two numbers is negative 9, not positive 9. So again, the two numbers are not equal. All right, take a minute. Identify the equations here that show the commutative property. So hit pause, and then you can hit play when you're done and see if you chose the right ones. Well, those two are commutative property. 7 plus 11 is equal to 11 plus 7. The numbers just flip, change the order. And in the bottom one, it's a problem that has the parentheses in it. So they're all multiplication signs. The 3 is in front of the parentheses, and on this side, the 3 is behind the parentheses. The two numbers in parentheses are still the same. I think if you solve that, you'll get 54 on both sides, and this one up here will be 18 on both sides. The top problem here is not correct because it's division. So if you see division, just cross it out right away. And the problem here is not correct because you can see that the numbers in the parentheses are different on both sides, and the numbers outside of parentheses are different. So that's going to be a different property that we're going to learn about in a second. Okay, property number 2 is the associative property. This changes the grouping. So that problem I was just talking about actually showed associative property. So the grouping of numbers is done with parentheses or some other kind of grouping symbol. So we're going to see that numbers are going to be grouped differently using those symbols. This property applies to addition and multiplication just like the commutative property does. Here's an example. So here this looks kind of like one of those commutative property problems where all the signs are the same, but the difference here is that the numbers are changing their order. So the numbers that are inside the parentheses are different now, and the numbers that are outside of parentheses are different. So we're grouping them differently by putting different numbers inside of parentheses. So 5 plus 8 is in parentheses here, 8 plus 9 is in parentheses here. But the order of the numbers, I think I may have misspoke a second ago, the order of the numbers is exactly the same. 5, 8, 9, 5, 8, 9. So the parentheses moved, the numbers did not. If we solve these using PEMDAS, we get 13 for our first step here and 17 for our first step here. And if you add 9 plus 13, and if you add 5 plus 17, you're going to get 22 on both sides. Here's an example using multiplication. Every sign is multiplication. The numbers are in the same order, 2, 4, 7, 2, 4, 7. What's different is where the parentheses are. So here the 2 and the 4 are in parentheses. Here the 4 and the 7 are in parentheses. So if I solve step 1, 2 times 4 is 8, 4 times 7 is 28, and I can follow and do step 2. The problem does not look the same. However, when you do your multiplication, we know 8 times 7 is 56 because that's a times table. 2 times 28 will also equal 56. So why not subtracting or dividing? So let's look at an example again. The not equal to signs in the middle, this is a subtraction example. So if we do our steps here, we get 3 for these parentheses, 2 for these parentheses, and then when you subtract here, 12 minus 2 is 10, 3 minus 7 using keep, change, change would be negative 4. So again, the problem looked like associative property at the beginning. The signs are all the same, the numbers are in the same order, the difference is that the parentheses move. So, but what's not associative property is that the signs are subtraction. They have to be adding or multiplying. Division, same problem. We're going to get a different answer on both sides when we solve. Here it's 24 divided by 3. Here it's 3 divided by 2. Well, the first one we know is 8. 3 divided by 2 is actually 1.5 or 1.5. When we finish dividing, we get 8 divided by 2 is 4 on the left-hand side, and 24 divided by 1.5 is actually 16, so not equal. All right, take a minute, hit pause, choose the ones that show associative property, and then you can hit play and see how you did with choosing them. The only one that's associative property is the third one. The first problem is division, so just cross it out right away. The second and fourth ones are both examples of the commutative property, not the associative property. They're changing the order, not the grouping. The only one that changes grouping is this third one here. The order of the numbers is the same. It goes 4, 5, 6, and on this side 4, 5, 6, but the parentheses are around different numbers. If you solve both sides, I think you'd get 120 on both sides, so they would be equal. Okay. Next property, identity property. This one is a fairly simple property. It just says that when you add 0 to a number, the number stays the same, or when you multiply a number by 1, the number stays the same. So let's take a look at some examples. It doesn't matter whether the number is a decimal, a fraction, negative number, positive number. If you add 0 to it, its identity stays the same. It's called the identity property because if you think about what the word identity means like everything about a person, right? Their name, where they live, who their friends are, what their hobbies are, how old they are, how tall they are, what color hair they have. So that's the identity property. 5 has a specific identity. When you think of the number 5, you have a specific thought in your mind. And if you add 0 to 5, and you think about what the answer to that problem is going to be, you're going to have the same thought in your mind. Whatever 5 means to you is what you're going to think about. Okay? So the identity stays the same. Multiplying, same thing. When you multiply by 1, it doesn't matter if it's a fraction, decimal, whole number, negative number, positive number, it's going to stay the same. So you can see some examples here. All right? So that's a quick run through. Take a second, look at these, be careful, and look at them. Hit pause, find the ones that show identity property, and then hit play, and we'll see if you chose the correct ones. There are your correct properties. Adding 0 stays the same. Multiply by 1 stays the same. Multiply by 1 stays the same. Here, 4 times 0 isn't even 4, so that problem's incorrect. 5 plus 1 is not 5, that's incorrect. So if this sign was different, if that was a times sign, that would be right. If this was a plus sign, that would be right. Here, it's plus 1 and the fraction is different, so not identity property. Plus that problem's incorrect too. All right, so next one, inverse property. We're going to go use some words that we learned earlier in the year here, opposites and reciprocals. Adding opposites equals 0. So if you remember what opposites are, like negative 5 and positive 5 are opposites. They're the same distance from 0. When you add numbers like that together, the answer is going to be 0. Reciprocals, what you'll remember, is that is when you take a fraction and you flip it upside down. So opposites here, two numbers that are the same distance from 0. Reciprocal is when you flip a fraction. So remember we used keep, change, reciprocate. We're going to use that later in the year when we divide fractions. So you're going to learn about that later in the year. Okay? So here's some examples of adding opposites and getting 0 as an answer. This is the additive inverse property or the inverse property of addition. Opposites equal 0, opposites equal 0. So you can see sets of opposites equal 0. It doesn't matter if they're decimals, fractions, whole numbers, negative numbers, positive numbers. If they're opposites, the sum of those two numbers will be 0. Same thing with reciprocals. So the top one here, 2/3 and 3/2, you flip the fraction. The reason this property works is that if you do 2 times 3, you get 6. If you do 3 times 2, you get 6. 6 over 6 equals 1. Same thing with this one here. If you multiply, you're going to get 44 over 44, which equals 1. I want you to pay attention to the ones that have a whole number in them. So the way you find a reciprocal for a whole number, so if I ask you what the reciprocal of 8 is, what you would do is you would write 8 over 1, because that's how you write a whole number as a fraction, and then you would flip it. So here, if I want to know what the reciprocal of 1/5 is, the reciprocal of 1/5 is 5 over 1. But when you write that, you're allowed to write that without the bottom part of it. So you can get rid of this part, and the reciprocal is just 5. Okay? So keep that in mind when you see whole numbers. The reciprocal of a whole number will be 1 over that number. Okay? And when you multiply those, you're still going to get a product of 1. All right, take a second, be careful again. Pick out the ones that show inverse property, and then we'll see how you did. Okay, here's the examples for those. Opposites equal 0 when you add. Reciprocals equal 1 when you multiply. And remember, 17 would be 17 over 1. I know I'm writing really sloppy, but that's how that would look. This doesn't work because it's subtraction and not addition. This one doesn't work for a couple of reasons. One, this would need to, they're opposites, and one of them would need to be a fraction of 1/11. So take away the negative sign, make one of them 1/11, and it would work. And the one down here, if that was multiplying, that would work. Okay? Next property, maybe the easiest property of the set, the 0 property. This says when you multiply a number by 0, the answer is 0. So here's some examples. Anything, fractions, decimals, negative numbers times 0, the answer is 0. This probably you already know. We're just naming it as an official property just so we can use it for a number of different things in different types of math problems. Okay, so here, real quick, hit pause again. Find the ones that are 0 property of multiplication, and then hit play and see how you did. Okay, there you go. Those 3 are times 0 to equal 0. This one, subtraction, doesn't count. The answer to that would be 15. This one is multiplying opposites, so that would actually equal negative 121. And this one is showing kind of the inverse property, but the answer is wrong also. That would be, the answer to this would be 1, and if it was 1, then it would be actually the inverse property. Okay, getting towards the end here. Distributive property is one that you're going to use a lot, and this is an important property. We're going to see how you can change a number that looks, or a math problem that looks like this into a different math problem. So what you can see here is distributive property is set up in this way, where you have an addition or subtraction problem inside parentheses, and then it's multiplied by a number outside parentheses. So remember, and one other thing to remember about the multiplication is that if you don't see a sign, it means to multiply. Okay, so if you see a number against a parenthesis, it means multiplication. So it's always going to be addition or subtraction inside parentheses, multiplying outside parentheses, and what you can do is turn it into this, and I'm going to show you how to do that. It'll turn into something that looks like this. Okay, so how do we do that? Or how does it work? That's what I'm going to ask you. How does this work? So the way it works is this. You start out with your problem here, and you take the number outside parentheses, the 3, and you multiply it by the first number, 6. You write that over here, 3 times 6. The next thing you'll do is take the plus or minus sign that's inside the problem and write that next to the 6. And then you'll go and take the 3 again and multiply it by the other number that's inside parentheses. So you set up a problem where it's 3 times 6 plus 3 times 4. And what we're going to do is we're going to solve this, and we're going to see that both sides will be equal when we solve it. Okay, so what I just did here with the red and the blue, that is distributive property. We're distributing the 3 to the 6, and we're distributing the 3 to the 4. If you don't know what the word distribute means, it kind of means to hand out or give out. So we're giving out the 3 to the 6, and we're giving out the 3 to the 4. So let's solve this to make sure it works. Let's prove it. Okay, so if we solve the left-hand side, the first thing we do is 6 times 4, or 6 plus 4 is 10. So 3 times 10 is what's left over on that side, and 3 times 10 is 30. On the right-hand side, let's start out by doing our multiplication. Let's use PEMDAS. 3 times 6 is 18. And then the second step, 3 times 4, that's 12. And if you add 18 plus 12, guess what you get? You get 30. So 30 equals 30. Okay? So here's what I want you to do. You can solve these if it helps, but do your multiplying, your distributing, and see which of these problems shows distributive property. So hit pause, find those, and then hit play and see if you chose the correct ones. Okay, those are the 2 correct ones. What we have here is 12 times 5 and 12 times 3. Instead of writing it out as the 12 times 5 minus 12 times 3, I just solved them because they're times tables, and you should be able to do those in your head. 12 times 5 is 60, minus sign after that. 12 times 3 is 36, and there's your distributive property. The third one works because you're allowed to put a times sign here, and there's a plus sign in the middle of 2 numbers inside parentheses. 3 times 7 should be your first step, plus sign in the middle. 3 times 5 is the second part of it. The second one here doesn't work because the plus sign and the times sign are reversed. They're in the wrong places. So the distributive property does not work when the plus sign is outside and the times sign is inside parentheses. It'll give you 2 different answers. And here, the person almost got the distributive property right. The only problem is they did 5 times 9, but they did not do the second step of 5 times 2. The person just carried the 2 outside. So that's why that would be incorrect. If this said 5 times 2 here, let me write all sloppy, then that would be distributive property. Okay? Last property. I know we've had a lot, but most of them are properties you already know, so hopefully there isn't a lot of new stuff in here for you. Properties of equality. All this says is that when you're given 2 things that are equal, so here A and B are equal, what you can do is you can replace them with each other in math problems, basically. So here's some examples. So if A equals B, then 14 plus A equals 14 plus B. So like if A and B were both 2, A and B would both be 2 in this problem here, and both sides would be equal. That works for addition. It works for multiplication. It works for division. And it works for subtraction. We're going to use this concept later in the year when we learn about solving equations, but basically A and B are interchangeable. They're equality. They're equal. They show equality. So that's really the property. So you can just replace one with another. Okay, so remember that the order matters in subtraction and division problems. If that's an important thing to remember. If this said B divided by 48, if this was switched, it wouldn't be equality. If this was B minus 3, it would not show the property of equality. So with adding or multiplying, the order can be changed, remember, because that's commutative property. But here, you can't change the order with these 2, so the order matters. Okay, so last practice page, choose the ones that show the properties of equality, and then hit play and see if you chose the right ones. No, there is only one. This one is the multiplicative property of equality, or the multiplication property of equality. The first one does not work because one is adding and one is subtracting. The third one doesn't work because, like we were saying just a minute ago, the order matters with division. You can't switch the order. And then the last one doesn't work because you have different constant terms. The 5 and the 7, they're called constant terms. They're different. So if they're different and A and B are equal, you're going to get different answers on both sides. Okay? So that's it. Lots of properties. So you probably want to go through this video again later on, or use it when you're studying for your test, when you're doing your homework, that kind of thing. So hopefully you learned a lot today, and I'll see you next time.